Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is unique number of occurrences and it is an easy level problem. So the problem statement says that we have been given an array of integers and our task is to find whether the frequency of elements in the array is unique or not. In other words, they're trying to say we have to find out the frequency of all the elements present in the array and we have to tell whether each element has unique frequency or not. For example, in this particular case, they say that 1 and 5 both have the frequency equals to 2, right? So that is why the answer should be false in this particular case. And if you come to the second example test case, this is the given input array and they have shown us the frequency of all the elements. So the frequency of 1 is 1, the frequency of 2 is 4, the frequency of 5 is 2 and the frequency of 10 is 3. So you see all of these values 1, 4, 2 and 3 are unique and none of them are same. So that means the answer should be true in this particular case. So this is all they are saying, and they say that the expected time and space complexity is both O of n. Now I'll tell you something about this question. First we need to have a look at the constraints. N is 10 to the power 5 and for the value of array of 5 it is minus 10 to the power 9 to 10 to the power 9, right? So I want you to have a look at this constraint carefully and then we are going to discuss something about it. So these are the constraints. And Geeks for Geeks has once again does what it generally does. They always assume that an unordered map takes O of 1 in all scenarios, right? So we have discussed multiple times that in the average case it takes O of 1, but in worst case it can take up to O of n square. So whenever they give this expected time and space complexity, they give it with this assumption that it is going to be in average case. And I'll tell you, like even if you don't like use unordered map, even if you use a regular map and do all operations in log n, the constraints or n are such that you'll still be able to pass the test cases because they are up to 10 to the power 5 only. But then in that particular case, the expected time complexity will be n log n, right? And not O of n. So that is why we are forced to use unordered map, and let us see how we can solve this with unordered map. So basically one way of doing it is, first of all you can store all the elements in the map. For example, we have elements 1, 1, 5 and 2, 2. This was the first sample test case, I believe. So when you store this in the unordered map, you will have something like this. 1 will have frequency 2, 5 will have frequency 1 and 2 will have frequency 2, right? Now what you can do is you can create an array or any data structure you like of size n plus 1, right? So if this is of size n plus 1, let's say there were 1, 2, 3, 4, 5. So there should be 6 places in here, 3, 4, 5, 6. So this is 0, 1, 2, 3, 4, 5, right? So why did we create a vector of size or an array of size n plus 1? So in this particular array, the ith position is going to denote the number of elements with frequency I, right? So the ith position is going to denote the number of elements with frequency I. So initially all of them are 0, and as soon as I encounter this particular 2, I say that there is one element with frequency 2, so I increment it to 1. Then I encountered this particular 1, I say there is one element with frequency 1, so I increment this to 1, and again I encounter an element with frequency 2, so I have to increment it and update it to 2, right? So now what you can do is you can just traverse through the whole frequency array and find an element which is greater than 1. So if there exists any element that is greater than 1, that means your answer will be false. Otherwise, if there is no such element, your answer will always be 2, right? So this is how you can solve this problem, and we are forced to use unordered map. We are forced to use unordered map because the range of array of I is very huge. If the value of array of I, let's say if the value of array of I was from minus 10 to the power 5 to 10 to the power 5, right? Even then we could have found some method to not use unordered map and make a pure O of n solution. In that case, what you could have done is you could have had an array of size 2 into 10 to the power 5 around this particular size, and for each element you can apply an offset of 10 raised to power 5. So for example, minus 10 raised to power 5, if you have this element, you will add 10 raised to power 5 and this particular element will be stored at position 0, right? And this last element 10 raised to power 5, you will add 10 raised to power 5 to it, and then this element will be stored at 2 into 10 raised to power 5 position, right? So you can take plus 10 just for safety and just to ensure that there is no overflow errors in the total size of the array, right? So you could have applied this offset of 10 raised to power 5 to every element, and then you could have stored this whole range inside an array. The benefit of storing inside an array is that you will be able to access the frequency of all the elements in O of one time and even update the frequency in O of one time. But we are just assuming that this unordered map is going to work in the average case, and that will be also constant. So anyways, you need to somehow store the frequency, and for the second part you can create this simple array where the ith position of the array will store the number of elements with frequency I, and whenever you encounter an element which has a value greater than 1, that means there are 2 elements or more than 2 elements with the same frequency, right? So that is why at that particular point you have to return no. So this was all about today's problem of the day. Now let me just show you the code. So this is the vector or the final vector that I was talking about. It will store the total frequency. So it will actually be used in the second part of our question. Now what I do is I create an unordered map, and what I do is for all the elements I just increment its frequency in the unordered map. Now I just traverse through the unordered map here in this for loop, and for each of the frequencies I increment it in the total frequency array, right? Now if any element in the total frequency array is greater than 1, I just directly return 0 from here, otherwise at the end I can return 1. So this was all about today's problem of the day. Again, you can also change it to map here. Only map, I have tested it and it works, and that is because the value of n is suitable up to 10 to the power 5, so n log n operations would be supported. So let me just quickly submit and show you that this particular approach works. You see, it passes all the test cases and the solution is absolutely correct. I don't know why it took so much time. So anyways, I hope that you guys were able to understand the solution. If you guys did, consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and to be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos and not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.